this oversampling, when we will use this oversampling and undersampling, why do I need that? Okay, so like these things are required if my data set is not balanced. Okay, so that's what I told you last time, so no problem. We'll also see like there are some variations of KNN. Okay, I'll just move here. Okay, there are some variations of KNN. Like what will happen that KNN will give equal weights, okay, to every class. But in weighted KNN, what will happen that it will give more weight to a particular class. Okay, so let's try to understand this. How will this weighted KNN work? Okay, okay. So basically, it's like this: weighted KNN. Okay, so like what will we do in this? Suppose we have these points, okay, and we have the green points. Okay, these black points and green points I have. Now if I have a point, okay, so if k equal to 3, and what will it do? It will find the nearest 3 points. Okay, and then what we did a voting kind of mechanism. Okay, voting, and the majority, okay, the majority wins. Okay, that this is the thing that happened. But now what will we do? We will give some weight. Okay, uh, suppose this feature is important. Okay, this feature is more important than this feature. Okay, this feature is more important than this feature. So what will I do? I will give a weight. Suppose I give a weight of 2 to this. Okay, and this will have a weight of 1. Okay, so now what will happen that whatever will be the count of this black one, I'll multiply it by 2. Okay, so its value will become 2. Okay, for the black one, the value will become 2. 1 second, yeah. Okay, and for the red one, it will be how many are red? Okay, 2 into 1. Okay, so it will also become 2. So like this is a case of tie. So okay, so that's why like we can choose some other weight. Like if we choose a weight of 3, okay, then this will become 3 into 1, 3. Okay, so then that point will be classified to the black point. Okay, so okay, so the meaning of W, you can also make it like this. Suppose weight is equal to 2. Okay, so that means that this feature is 2 times, okay, more important, okay, to other features. Okay, so this is the simple meaning that you can get out of this. Okay, so this is one of the like variation of weighted this KNN. Okay, we can also give weight to every class. Okay, every class, sorry, this will be other class, not features. Okay, this class, okay, is 2 times more important than other class. Okay, let's see what is the other variation. Okay, k minus I NN, which means that here the threshold is I. If out of k, if I votes are taken by the candidate, then only it wins, otherwise we don't classify a candidate. Okay, so in this k, okay, k k dash I. Okay, what happens in this k dash I? Okay, so we have another variation of KNN, k dash INN. Okay, So here what will we do, that I will set a threshold. I will set a threshold. Suppose I set a threshold of 3. Okay, so what will happen, that I have the points. Okay, I'll just draw them rounded. Okay, and just with the other color. So what will happen if k equal to suppose 4. Okay, suppose k is 4. Now, okay, suppose a point is here. Okay, so nearest point would be 1 2. Okay, maybe this 3 and this is 4. Okay, let's, sorry, k equal to 5 we shall do, because 4 can lead to a tie, na? So k equal to 5. So this one and this one. Okay, so the black one will have 3 and red one will have 2 count. Okay, so what will happen, that if the count of any class, okay, is greater than equal to threshold, okay, then only we classify that point to that particular class. Okay, here though it is greater than equal to the threshold. Okay, now suppose the threshold was 4. Okay, suppose the threshold was 4. Now what will happen, then this point will not be, okay, it will not be classified. Okay, it will not be like classified, simply it will not be classified, we will not classify it. Okay, because sometimes what happens, that we want the accuracy to be very high. Okay, I want to be more certain that whatever is my new data point. Okay, uh, okay, so I should be sure that it should belong to this class only. Like I gave you an example, na? Like like if we take a simple example. Okay, so these are my points, these are my red points. Okay, now if we talk about these black points, okay, these black points means that a person is not, okay, not corona positive. Okay, not corona positive, and here it is corona positive. Okay, so in which case should I need more accuracy, like should like I told you, the test. Okay, we do the testing, and testing can be correct also. Okay, and it can be wrong also. Okay, so this test can do two things. Okay, first, a person is actually positive. Okay, but the test is classifying it as negative. Okay, and a person is actually negative, but test is classifying him as positive. Okay, so which situation is more dangerous? Which situation is more?
Second one,
Why?
because that person is corona negative, but they're showing it as positive.
What about the first one? Is it okay?
And that is also dangerous.
Which one
Both
would,
are dangerous.
I guess that this one will be more dangerous. In reality, he is corona positive. Okay, this will have more consequences. Okay, because test is saying he is negative. Test is saying that he is negative, but in actual he is corona positive. Now what will happen? This corona positive person will think that I am negative, and he will go around everywhere and he will spread the virus. Okay, but in this case, what will happen? Suppose a person is negative and we mark him as positive, so like he will just go under the treatment. That person will go under the treatment, although that would not be good for that particular person. But if we talk about the consequences, okay, so the consequences of the first thing will be more dangerous. Correct, the consequences of first thing would be more dangerous. Now what will happen, that uh, suppose, okay, I'm using KNN classifier. Okay, I have some data of corona positive negative patients. Okay, now what will I do? There is a person, okay, so okay, these as per his characteristics, okay, so these would be some parameters like number of days, okay, number of days he is sick, okay, number of days he's sick, and the other feature could be like whether he's having any pain also, okay, what is the severity of pain that he's having. Okay, now suppose I got a point like this, okay, now what will happen, that that it will see the nearest neighbors. Okay, now suppose I took k equal to 5, I took, okay, k equal to 5. Now what will happen, that the nearest k point is 1, 2, 3, 4, and 5. Okay, so black one gets the 3, okay, 3, okay, black one gets 3 point and red one gets 2 point. Okay, so okay, so one case is this, so here I will mark him as this black one, that means he is corona negative. Okay, now what I do, I set a threshold, I set a threshold uh, of 4. Okay, so here 3, red is equal to 2, and here it will be undecisive, it will it will say that I don't know, I cannot predict, it will just say that I cannot predict. Okay, so like why we are doing like this, because if if like suppose I will remove this. Okay, suppose that the black one has the black one like suppose there is another black one which is more nearer to it. Okay, now what will happen, that black will have 4, okay, and red will have 1. Okay, red will have 1. Okay, and this classifier is also saying that he's not corona positive. Okay, so which one do you think is like more sure, which one of them is more sure, this first one or second one? Okay, so if we calculate the uh, percentage, okay, percentage of the black ones, here it is 3 upon 5. Okay, so we'll divide by 100, so here it is 60% sure. Okay, that this belong to the black ones, that means he is not corona positive. But if we talk about this, okay, here it is 80% sure. In this case he is 80% sure that he is corona positive. Okay, so so that's why where we need to have more surety, okay, there what will we do, we will put a threshold. Okay, now if a person is over here, then obviously he will be in the corona negative part. Okay, he will be corona negative. But if he lies in this part, then definitely he is positive. But if he is lying somewhere in the middle, okay, then there will be problem. Okay, then we cannot decide that whether he is positive or negative. Okay, so like this is one of the scenario, okay, where we do a small modification in this KNN algorithm. Okay, so like what are the advantages of KNN algorithm? So first is that it can be applied to any kind of distribution. Okay, so the meaning of this statement is that if we talk about logistic regression, okay, if we talk about logistic regression, so can you tell me whether logistic regression will be able to separate these data points? Will logistic regression will be able to separate these data points or not? What do you think? Okay, so logistic regression, okay, logistic regression logistic regression will work, okay, for only the linearly separable data. Okay, so the meaning of linearly separable data is that the data which can be separated using a straight line. Okay, so it is like this. Like if we talk about these points, so we can separate these points using a straight line. Okay, but in this case we cannot separate. Okay, so here my logistic regression will fail. Okay, so but do you think that my KNN will work over here? Okay, so KNN will definitely work over here. Okay, because if a point is lying nearer to this black one, he will mark it as black, and if he's in the red region, then it will mark it as red.
So your screen.
Okay, so okay, okay, if he's in the red region, then okay, these red points will be more near to him. Okay, so then he will mark it as red, but here it will mark it as black. Okay, so that is the advantage. Okay, KNN will work for non-linear, okay, non-linearly separable data. Okay, but my logistic regression will work only for the linearly separable data. Okay, so that is the advantage of KNN. This is one of the advantage. Okay, and if we talk about other advantage, that if the data number of data points are very high, then we get very good results. Okay, so this is one of the advantage, and another advantage is that it is very simple to interpret. Okay, so suppose that my KNN algorithm said that a person is corona negative. Now I want to know why he is corona negative. Okay, I want to know why he is corona negative. Okay, so what will uh, what can be the like what can we infer out of it? Okay, suppose for this point, okay, because this point is nearer to these black regions only. Okay, so my KNN will say that he is corona negative. Okay, he is not corona positive. So what will happen, that I want to know why he said that. Okay, why KNN algorithm classified him as corona negative. So this is like pretty simple, that the nearest point, okay, nearest point, okay, to nearest 5 points, if we are taking k equal to 5, okay, nearest 5 points, okay, all of them belong to corona negative patient only. Okay, so that's why I will also say that this person is corona negative. Okay, so like that is the, okay, advantage of KNN, that whatever results KNN is giving me, I'm able to interpret why it is giving me. Okay, although like it works for logistic regression also, you know, but there are some algorithms like deep learning where it is difficult to interpret why it has given a certain result. Okay, but in case of these KNN, it is easy to interpret. So this is also one of the advantage of KNN. Okay, and what are the disadvantages of KNN? Okay, so it is highly dependent on the value of k. Okay, so yesterday also I told you, if k is very less, okay, k is equal to 1, then what will happen, whether it will be overfit or underfit if k equal to 1. Yeah, come on, like if k equal to 1, then what will happen?
So overfit.
It will overfit, and if k is very large, then it will underfit. Okay, so that is the thing, like I should select the value of k properly. If I don't do it, then my model will fail. Okay, the other thing is that it is very computationally expensive. Okay, so the meaning of computational expensive is that suppose I Okay, what will happen that I okay, what will I do? I built a application. Okay, I built a website where I'm using KNN classifier. Okay, a patient will come. Okay, a patient will come. He will give me his features. Okay, he will tell me for how long he has been sick. Okay, how much pain he is like having, and like whether he's having he's sneezing or not. Okay, so these kind of features he will input, and my application will give me the result, like whether he is corona positive or whether he is corona negative. Okay, now what will happen that there will be many users which will be logging into the site. Okay, now what this KNN will do, for every user, okay, it will find the nearest K point. Okay, so okay, so but it will take time. It will take time. So what that means is that this page will hang. With this page will hang a lot. Okay, but why it will hang? Okay, let's see why it will hang. Why this I'm saying KNN is very computationally expensive. See, it is like this. So these are the points I have, and I get a new point. Okay, now what I have to do, I have to find the distance of this point from every other point. Okay, so distance of this point to every other point. So this portion, okay, if you have studied complexity, okay, so this will take order of n time. Okay, where n is the total number of data points that I have. Okay, so this is the first step. It will take order of n time, because for every point, okay, I'm doing some calculation. I'm finding the Euclidean distance. All right, in second, what will I do? I will sort. Okay, sort the distance. I will sort them in ascending or descending order, the distances. Please tell the distance that I will find, all the distances. What should I do? Should I sort them in ascending or descending order?
Ascending order,
Why?
because the one which will be the less amount of distance from the point
Mm-hmm.
will be closest to the point.
Mm-hmm. Correct, correct. Okay, so how much time this will take sorting all of them? Okay, so if you have studied sorting, then you would be knowing that it will take n log n time, or n square time. Okay, so like no need to focus on this n square time. Just think that it will take a lot of time. Sorting will take a lot of time. Okay, so this is the second step. In third step, what we will do, we will find the first k points. Okay, first k points, okay, from this sorted array that I got. Okay, from this first k elements, we can say. Okay, not points, elements, first k elements. Okay, so this is the like thing. Okay, so that's why for every person I will be doing these steps. For every person I will be doing these steps. Okay, so that's why it will take a lot of time. And if I like deploy it, okay, in okay, if I make a website using KNN, then my website will hang a lot. Okay, so that will be of no use. Suppose you you would be using Google Translate. Okay, and if you say something and it is giving you the okay the okay, what it does, you speak something and it writes it down, na? It is giving you the response after like 1 minute. Then what is the use of that? Okay, so that's why like this algorithm is computationally expensive, but that doesn't mean that this algorithm don't have use. Okay, it has use where we want our model to be very simple, so that we are easy to interpret the results of it. Okay, so That is one of the advantage of KNN. Okay, okay, it's very computationally expensive. Other part is that no training stage, all work is done during the testing stage. Okay, because I told you that it is a memory learning algorithm, you know, lazy learning algorithm. So it will not learn anything in the training part, it will be learning in the testing part only. Okay, and other thing is large amount of data is required for it to be accurate. Okay, and do not learn which features are more important, as it uses all features for classification. Okay, so by default it will not learn the important features. Okay, although we can like modify it, okay, to give special more importance to a particular class. Okay, but it will not be able to find, like in case of logistic regression, what was happening, in case of logistic regression what was happening, can I find which one is the important feature? Like suppose I have a data, okay, in which I'm predicting the salary. Okay, I'm predicting the salary of a person, so I have some information about that person. I know the experience, okay, how much experience he have. Now first one is this. Second feature we can take that which college he has studied, which college he has studied. Okay, and the domain he's working on. Okay, the domain he's working on. So I have these features with me. Okay, and using these features I need to find the salary of a person. Now what will happen, that if I have okay, the linear regression. Okay, the linear regression equation will look like this: beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Okay, now when I run the linear regression algorithm on the data, then I get some values. Okay, I get the values for all of them. Okay, so for suppose here I'm getting zero point 0.7, here I'm getting 0.3, 0.2, or okay, zero point 0.8 we can say. Okay, zero point 0.8. So here we can see, suppose this is zero point 0.8. So by looking at this, what can we say, which feature is most important? By looking at these coefficients, like this beta is having the highest value. Okay, and this beta is corresponding to the experience. So by looking at this I can say that experience, okay, experience feature is the most important feature, है ना? This thing we can interpret using the linear regression. But in case of logistic regression, what will happen, sorry, in case of KNN, okay, I will not be able to do that, because what will happen, that okay, I'm just calculating the different distance. Okay, I'm not finding any coefficients over here. Okay, I'm not finding any coefficients in this KNN, so that is why. Okay, so this is one of the disadvantage. Okay, and like there is actually no one more, yeah, one more disadvantage. Okay, so this we have discussed. So this is data need to be normalized, otherwise KNN will not perform good. Okay, now what is the meaning of this statement? That okay, so can you tell me that why do we do normalization? What is the use of normalization? What is the use of normalization? Okay, so suppose I have height, and height is in centimeters. So height is 160 centimeter, and weight is in kg. Okay, so it is like 80, 70, or 60 kg. Okay, and these are 170, 180 centimeters. Okay, Let me take other example of income. So income is like 1 lakh. Okay, income is 1.5 lakh. Okay, 2 lakh. Now what will happen that my a new point will come, okay, to the KNN. Okay, new point will come to the KNN. It will okay. So what I need to do, I need to give it a class. Okay, so I will also have a class variable. Okay, so suppose I'll say that he's medium. Okay, he belongs to the medium class, he belongs to the high class. Okay, he belongs to the medium class. I'm just like making a generic okay data model. Okay, data, I'm creating a generic data. Now what will happen that I will find the I have a data point where the height of the person is 175 and the weight is 70 kg and his income is like 1 lakh rupees. Okay, then what will I do? I will find the Euclidean distance. And how will I find the Euclidean distance? I will write like this. Okay, for every point I will find the Euclidean distance. So what will happen? 175 minus 160 whole square plus 80 minus 70 whole square, okay, plus 1 lakh minus 1 lakh whole square. Okay, so like here though it is happening that it is becoming 0. Okay, like suppose the person's salary, okay, is like 5,000 over here. Okay, 5,000 over here. So what will happen that these value will be very negligible compared to this value. Okay, this value will be uh, the algorithm will give more weight to this. Okay, why? Because the magnitude of this is very high. Correct, magnitude of this feature is very high, but I don't want that. Okay, I don't want that, so that's why we normalize the data. No, we normalize the data, and same thing we did in logistic regression also. Okay, so in normalization what we do, okay, x minus x min whole upon x max minus x min. Okay, we apply this transformation on every feature. So now what will happen that it will give same weightage to every feature in my data. Okay, so that's why like it is important to normalize my data. Okay, in case of KNN, and if I don't normalize it, it will give more importance to that feature. Okay, which is having values in a like larger range. Like here we saw that income was having a larger order, okay, magnitude, so that's why it was giving more weightage to it, you know. So that is the thing. So this is the disadvantage of KNN. And okay, so yeah, these are the things that are there in KNN. uh, this was related to some other topic. uh, okay, so no need to like see it right now. We'll see the code now. Okay, we'll see the code. So we'll see from scratch. 1 minute, just give me some time. Okay, from scratch. Okay, so here what am I doing? I have a data. Okay, I'm creating a data over here, and just give me 1 second. I'll show you where is the data. Yeah, here I have created the data. Okay, so let me run this. Okay, I'll show you. Okay, the first 5 points. So you can see that this is my data. Okay, and so I have two features over here, and this is my y. Okay, so here we have 1 or 0. Okay, 1 or 0, like these are the different class labels that I'm using over here. Okay, and this is the function that I have used, that is make classification. Okay, so 500 number of samples I have created and two features I'm creating. Okay, and n redundant means that I don't want any redundant data. Okay, that means that any row should not be copied again, all the rows should be different. Okay, and I'm not sure about what does this mean, n informative. Okay, and number of clusters per class means that there should be one cluster per class. Okay, I'll wait, I'll show you this part. Okay, and random state 14, so you already know. Okay, that if I specify a random state, then same data will be produced every time. If I don't specify the random state, then every time different data will be produced. Okay, so it will create problem for me. So just give me 1 second. I will just show you the data also. Okay, I will show you in the yeah, I'll use this one. Let's see, let me import the cbound package. Okay, so here you can see that these blue ones are okay, belonging to 0 class, and this orange one are belonging to the 1 class. Okay, so the number of clusters per class means that there will be only one cluster, okay, of this blue. It will not create any different cluster like of blue over here. Okay, so there will be only one cluster of blue and orange. So that is the meaning of this. Okay, so you can see I have x and y, and I have the classes belonging to them. Now, what have I done? I have defined a function which will find the Euclidean distance between 2 points. Okay, so np dot square root. Okay, it will find the difference. It will square. Then it will find the sum of all the elements in the matrix, and at the end it will do the square root of it. Okay, so this is the thing. And I have made another function where what it will do, it will find the majority, okay, in a particular array. Like suppose I have an array, like here I have an array. So in this array, which element is having the majority? Which element is having the majority? 1 or 0? Okay, so
So 0.
0
Zero.
is having the majority, no? Because 0 is coming 3 times and 1 is coming 2 times. Okay, so that's what we are doing. I am running the loop, okay, in this array. Then if I, so you know, if I means that if I is greater than 1, the meaning of this is, okay, like this, then I will increase the ones. Okay, otherwise it is 0, so I will increase the value of zeros. So if the zeros are greater, then I will return that it belongs to the 0 class, otherwise it will belong to the 1 class. Okay, so that is how I have defined this find majority function. Now now what will I do? Okay, I will show you how it will work. Okay, so k equal to 50 I have defined.
I have a doubt.
Yeah.
Above, if you go above,
Uh-huh.
there's one warning which shows that to import pandas. I'm not understanding that warning. Like, why is it we haven't like imported pandas, and why it is showing?
Pandas listing is deprecated. Use the function. Uh, Actually, like what would be happening is that there is some package over here, okay, which would be using pandas. Okay, like if I run this again, then it is not showing. But that why it shows the warning basically, that suppose I use a package, okay, which has been given a new name, okay, and I'm still using the package of old name. Okay, so then only it will give me that warning that it has been deprecated. It's better to use the new package that we have introduced. Okay.
Okay, sir.
uh, So here maybe some of the package would be using pandas, okay, inside it. So that's why it was showing pandas. Now,
Sir,
yeah,
so in that distance formula, why are we not taking the y coefficient? So y1 minus y2.
y1 minus
Because in the
y2.
distance formula,
Uh-huh.
and why we're doing the sum part, np dot sum.
See, I'll tell you. Actually, what is happening that I am passing the uh, 1 second. Actually, I am passing here. See, it is like this. I have three features: x1, x2, x3. You know, I have some value. Suppose the value is 10, 11, 12. Okay, I'm taking a like very bad example. Just ignore that. But just I wanted to tell you the concept that is happening. Now, what will happen that I want to find the distance between these 2 points. So what will be the distance between these 2 points? Please tell what will be the distance.
13 minus 10 whole square
Mm-hmm.
plus 14 minus 11 whole square plus 15 minus 12 whole square.
Okay. So what will happen that this data, okay, this will be stored in an array, you know, and this data will also be stored in an array. Okay. So what will I do? I will subtract each element. Okay. I'm doing the matrix operation over here now. Okay. I will subtract. Okay. When I will subtract this, suppose this is A and this is B. When I will subtract A minus B, what will be the result? Okay. So minus 3, minus 3, minus 3. Okay. 13 minus 10. Here it will be 14 minus 11. Here it will be 15 minus 12. Okay. So this will be my final array. Now what I need to do? I need to square this array. 999. Square, okay, all the elements inside this array. And in the end, what I need to do? I need to take the sum of all of them. Okay. So it will become 3 9 27. Okay. So will this be my answer? What I need to do more? I need to take the square root also, no? So the same thing, okay, the same thing I'm doing on the arrays. So that's why the the things have changed over there. Okay, because the formula that you studied x1 y1, okay, x2 y2, okay, uh, okay, in reality here what is happening that we have we have this x1 y1 x2 y2. Okay, this is another feature, this is another feature. Okay, and we have these values in an array. Okay, so like that is why this is happening. Gayatri, is it clear or
I understood, sir.
okay, like what would be the other way? Okay, if we go using the straightforward way, we need to iterate through every element of x and x1 and x2. Okay, then we need to find the difference, then square them, okay, and sum them and then do. But by using the matrices, I didn't need to run the loop. Okay, directly I found the answer. So okay, so now what we'll do, suppose we take okay, so we have divided my data set into x test and x train. Okay, I passed this x and y. I specified the test size to be 0.2. So okay, so let's take one instance, because I told you in KNN the training part doesn't happen. Okay, we get the test data, then we see the nearest k nearest point in the training data. Okay, so this is my test data x7. Okay, and for this x7 my actual output is 1. Okay, it's 0 over here. Okay, Now what am I doing? Okay, see, this is a comprehension I have used over here. Okay, just focus over here. This is a comprehension that I have used. For every point in the X train, okay, I'm finding the distance. Okay, distance between this new point that I have, the new point is X7, okay, and that current point, okay, that current point, okay. I guess you understand, no? Like what this xt will store. Okay, xt will store the first point in the first iteration, then we will be finding the distance. Okay, then again this will run, it will store the second point, then it will find the distance with the second point. And what we are doing, we are storing all these points in an array. Okay, so this is the thing that is happening. Now what will happen, that these are okay, these are distances I have stored in an array known as distance one. Now I have used a sort function over here, but I have used a arg sort. Okay, so what will this do? It will return me the indexes of those elements. Okay, so like let me tell you what is happening over here. Suppose like we have this x. Okay, so 1 2 3, I have y 1 1 or 2. Okay, suppose I got a new point that is 4. Okay, then what will I do? I will find the distance between 4 and 1, 4 and 2, so sorry, 2 and 4, and 3 and 4. Okay, so distance first will be 4 minus 1 whole square. Okay, so like this will be like here, so we don't need that formula, we can just subtract it. So what are the distances that I will get? 4 minus 1 is 3, 4 minus 2 is 2, and 4 minus 3 is 1. Okay, so these are the distances that I will get. So this is 0 1 2. Okay, now suppose k equal to 1 over here. Okay, so I should that means which distance should I choose? I will be choosing this distance. Okay, so you know, I will be choosing this distance because this is the lowest one. Now what this arg sort will do, okay, I will apply the arg sort. Okay, what will happen, that the sort, what will be the sorted order? Sorted order will be 1 2 3 of this d1. Okay, this will be the sorted order. Now what will we do, that okay, now its index will be 0 1 2, but I want to know the class corresponding to this distance. So how will I know that, to which class this it belongs? Okay, so this belongs to the second class. Okay, this belongs to the second class. So what this arg sort will do, it will return me the indexes, not the actual elements. Okay, it will return me the indexes. So what is the index of the smallest element? What is the index of 1? Please tell, what is the index of 1? The index of 1 is 2 over here. You know, index of 2 is 1 and index of 3 is 0. Okay, so arg sort will return me the indexes of the elements, not the actual elements. Okay, so that is the thing that is happening over here. So here what will I do? I will take the k nearest. Here k is equal to 1 in my example. Okay, so I will choose, okay, I will go in the y array. Okay, then I will go to that particular index. Okay, and from that index I will get the actual okay, label of that data, you know. So that is what this arg sort is doing. Okay, I founded the index of the elements, and then I took the first k elements. Okay, so these are the sorted distance. Okay, so this is not the distance. Okay, this is the index. This is the index of the okay, the point which is having the smallest distance with this x test. Okay, this is the second smallest, this is the third smallest, fourth smallest, and these are the index of that particular point. Now, okay, I will what I will do, I will extract, okay, all these okay, all the y corresponding to this particular index. Okay, so how do I do that? I just, okay, pass it inside a tuple. Okay, then what will it do? It will extract the element, okay, that is in y at this particular index 313, at 75th index, 312 index. Okay, and then we will store it in the result. After that, what we will do, we will apply the majority more voting, okay, which I already told you, whichever will have the majority, it will give me the prediction of that. Okay, so let's run what it is doing. Okay, so in reality it is 0, but I am predicting it to be 1. Okay, so the same thing I have done over here. Okay, the same thing I have done over here. Now what am I doing? I am doing it for every point in my x test. Okay, so let me run this, run all, then I will show you that what is the actual result. Okay, so for every element I'm doing the same operation. Okay, and this is my confusion matrix that I have got. So these are the correct ones. Okay, 50 I classified correctly and 1 I classified wrongly. Okay, and these are the points which I misclassified. So see, like how better is the accuracy over here. Okay, only 6 points I misclassified, rest all of them I classified them correctly. Okay, now if I okay, if I make the k equal to 1, okay, so then what will happen? Will the accuracy increase or decrease if k equal to 1? Let's see. Okay, now we have only 5 only 5 points. Like it should increase, the accuracy should decrease, but in this case it is not decreasing. Not a problem. Let's see for k equal to 5, k equal to 5. Yeah, for k equal to 5 it is giving me much better results, you know. So like k I was taking very large, k was 50, so that was giving me okay, bad results. So you can see that k equal to 5 is giving much better result. Only 3, okay, of them are being misclassified. Okay, so like this is the code for KNN. Okay, and I will also tell you a little bit more about this code. Okay, see, I have a data over here, okay, and it is having a particular distribution. Okay, so these things I have shared you in the Google Drive folder. Okay, so just don't focus on this red and blue part. Okay, just focus on these points over here. So in the data I have points which have distribution like this. Okay, so this is the first kind of distribution, and I have another data set that is U shape. Here the distribution here it is having a U, each class is having a distribution similar to a U shape pattern. Okay, you can see that this is a following a U shape. So here now I have another data concentric. Okay, so here it is concentric. Okay, this blue points are inside this points. Okay, so I have another kind of, that is concentric 2. So see, this is having a different, okay, distribution. This is having a distant, this is linearly separable. Okay, this is the way it is differentiated. Here it is a different distribution. Okay, here you can see that it is, okay, different. Here you can see it is different. So like what I'm doing over here, I told you this last time also. See, like I'm using a KNN comparison. Okay, what it is doing, I'm giving it the number of neighbors that I want. Okay, and my data. Okay, so this is my k, and neighbors means the k that I will give it to it. Okay, So what I will do, I will use this k nearest neighbors classifier. Okay, so see, this is present in sklearn, but where am I importing it? One second. Yeah, it is being imported from this, from sklearn import neighbors. Okay, from sklearn import neighbors. Inside neighbors we have this KNN classifier. Okay, so here we don't need to write all the code that I showed you. You can directly pass the x train y train and it will give you the result. So uh, I pass the x and y, and okay, I pass these x and y values. Okay, so this will be my test data set. Okay, I will pass this test data set to my this classifier dot predict. This is my x and this is my y. Okay, this thing I will pass it. Now what we will do, the predictions that I have, I will plot them. Okay, I will plot the predictions. Okay, and the actual data points that I have, I'm plotting them, okay, on a scatter plot. And for these I'm using a color mesh. Okay, color mesh. So what it will do, like okay, so my points will be like this. Okay, for every point, okay, it will give the color. Okay, so you can see if k equal to 1 it is overfitting, k equal to 5 also it is overfitting, k equal to 15 you can see that it's better, you know, k equal to 30 much better. But if we increase the k to a very large value, then like the accuracy generally decreases. See, k equal to 1 it's a overfit, k equal to 5 also a overfit. Okay, and k equal to 15, like this is more smoother. Okay, so the boundary which is more smoother, like that k value I should use. Okay, so here you can see that it is not very smooth, it is changing a lot. So this thing I don't want, and at the end it is like, but here k equal to 30 is performing much better. Okay, no, it's not performing better, like these points it is misclassifying. Okay, so if you will run this code on your system, then what will happen, that it will take a lot of time to train. Okay, and I told you why does it take a lot of time, because it is finding the distance with every other point. Okay, and then sorting them. Okay, and it is doing it for every point that I'm passing it in this grid. So that's why it will take a lot of time. So like if you have time, then only like run this code. Okay, because it will take a hell lot of time to, okay, run this code. Okay, so these are the things, and I have uploaded these both these notebooks in the Google folder. Okay, all right, so like that would be it in the KNN classifier. Okay, so like do revise it by your own. Okay, and we'll be meeting on Monday. Okay, so that would be it in this session, and thank you all for participating. Until then, bye bye.